Make sure I got my facts right here. 5 inches. I have 5 inches on a total of an 8-inch bolt. Okay, let's back that up.
Previously on XFrame. You can't keep me in this hole forever.
Yes, we'll see about that. My plan of boring you to death is working excellently.
Ha 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 ha. No!
Don't do that.
Hey, welcome back to Think Build Test, the channel where we are designing an X-frame lift. On our previous part 1, we showed you all of our spatial constraints of our X-frame and all the thought process we had to do to meet our goal indicators. On this episode, we're going to be talking about what we need to do to connect this thing. After a lot of thought and a lot of research, looking at other X-frames that used 5/8 or 3/4 inch bolts and pins, I decided since I want to bring this thing up on all of its strength levels that we're going to use 1-inch pins. So I've procured some 1-inch grade 8 bolts, and then we're going to have to design every other part of this around this. When it comes to moving parts, you have basically 2 options. You can either create a greased bushing, and that will allow these parts to be in here and have a bushing that you come and grease periodically with maintenance, or you can use sealed bearings in order to keep this lubricated and have less maintenance. Now, there is a third option, which I've seen on some cheap X-frames, and that is to just drill holes and let them grind on this bolt. I don't want to do that. That sounds like a future failure, and I want to build this for long-term success. One of the big problems about designing something your own is the parts don't exist yet. Yes, these parts may exist as a replacement part for a tractor, a car. So that makes it where you can go to the dealer, say, I want this part, and the parts exist. You can order them, bring them in, put them in, and they're ready to go. But when you're designing something, it's really hard to find helpful people that can tell you what sizes go with what. So there lies that there's going to be some trial and error in this. Now, some of the limitations I have in my shop is I don't have a mill. I don't have a lathe or a mill. So I don't have that function to be able to manufacture parts specifically. So I'm going to go out and get the things that I can get in metal and pipe and bolts and bearings that are the closest to the size that I can. So that being said, if I go with a 1-inch diameter belt, I need a 1-inch inside diameter bushing or bearing. Now, bushings are super hard to search on the internet, and they're even harder to find at your local stores. Pretty much for the simple fact that I can find the right keywords to search for bearings instead of bushings, I'm going to go with bearings on this build. I was able to find 1-inch inside diameter by 2-inch outside diameter bearings. They're going to fit my needs. Now that I know the diameter of the bolt, the inside diameter of the bearing, the next thing I needed to know what was going to be my shank length of my bolt. If you've ever went online and tried to order a heavy grade bolt, they do not indicate in the part number, well, readily available to the public, how long the shank length is going to be. They just give you the total length. So I went to my local bolt store and I just had to keep having them bring it out until we had the right shank length we needed. So since I needed a 2-inch stack up and a 2-inch stack up, that leaves me needing 4 to 5 inches of shank. To be safe, I got 5 inches of shank ordered, and that ended up being an 8-inch bolt in order to get that shank from this brand. To make sure I'm going to have a good secure connection, I went ahead and got nylon nuts to match the bolt. All right, so I got everything back up top so that I can work more freely around it. The good thing about filming your whole project is you can use this video to go back and check your space and rethink things without having to put it back. So that's one benefit to YouTube. The rest is everything takes 4 times longer. Let's talk about hardware management. In a project, your unknown costs that can eat your whole budget are around the hardware. This bolt, locally where I can get my hands on it and make sure it's the right thing that I want, is a $20 bolt by itself. This nut is like $2.50 for one nut. I think I got a package of 10 of these bearings for $20. Now we're getting to the part where I need your help in the comments. Now that we talked about the bolt, we gotta talk about how we're gonna get the outside of this diameter to match our beams. Naturally, the best thing we'd want is something that's a 2-inch tube or pipe inside diameter to fit nice where this can press in and be tight and square. Well, when we're talking about round pipe, there's two types of measurement. If you're talking about a pipe that fluid runs through, that's called pipe, and it goes off the inside diameter measurements. If you're talking about round tubing, everything is measured to the outside. Everything in 2-inch metal pipe has an overage. Nothing will be tight. So this 2 3/8 tubing that I have is going to be about the same. So as you can see in here, it's loose in here. Okay, so here is my dilemma. How do I shrink this diameter down to match 2 inches tightly? This is where I need your help in the comments. Tell me how I can do this safely. One thing that I've seen done to build up an inside diameter is to build up a weld bead in here and then grind it back out. But that's going to be very time consuming, and I'd have a lot of joints to do, so that'd be a lot of really precision grinding for me. I am not excited about that. Another option I'm thinking about is possibly sleeving this with some rolled sheet metal, but I have to be careful. If I get a dissimilar metal in here or a softer metal, then it could squish down. And I'd have to get just the right thickness. Now, a third option is I could potentially cut a line out of this and then crimp this pipe back down and re-weld it, but that could kind of oval this, but that might end up being one of the better options. What I'm thinking I'm going to do is I'm going to try several options and see how it works with being able to press this bearing in there. But let me know in the comments, what would you do to downsize this diameter? Let's get a little piece and let's see how this looks. Let's cut one off. Once we have it figured out how we're going to sleeve this, pinch this, whichever, the idea was going to be put a bearing on each side, take the bolt through, and now you'd have an opposing force to keep the bolt from twisting. So another problem that I ran into was finding a static load rating for bearings. How much can they handle? What is the rating on this? I don't know. I think that it was showing something around 1,800 pounds for one, but that was at a specific RPM, like 2,000 RPM. So what is it static? So what I'm going to do to be able to give us more buffer on that weight requirement is I'm going to double these bearings up. I'm going to have 2 on each side, and then I'll just have a spacer in between to hold the gap. Hopefully that will double my strength, and that'll also increase the surface area here for our sleeving. We'll have this 2.5-inch wide pipe in the intersection of the middle of this tubing, and we'll have these 4 bearings on one side, then we can have 4 bearings on the opposite side for the other beam. Now the other thing we're going to need is pivot joints and rollers. So to keep everything consistent and to be able to get bulk purchasing on the bearings, I'm going to create my rollers out of this same pipe, and I'm going to use the same pipe to create my pivot hinge joints. And I'm going to use 2 bearings inside the diameter of this pipe. I'm going to cut out a notch. That way I can have this pipe be inside this diameter, and then the pipe will act as the wheel caster. So once again, to be able to make this caster, I had to find out what the shank length would be, and I need a 2-inch shank to be able to bolt this here. Well, look at how much extra threads I have. So once again, I had to go locally here and buy a more expensive bolt. I think these bolts were around $10 a piece, and this is a 4.5-inch bolt to be able to get 2 inches of shank. One thing I'm probably going to be doing is Once I figure out exact lengths that I need, I'm gonna come back before I put this down in the hole and cut off all these threads, because it's way more threads than I need for this much shank. All right, so I'm gonna wrap up this think video and leave y'all to comment while we consider exactly what we're gonna do going forward for the hardware. So the next video you see, we're gonna begin our welding on the frame, getting those dimensions solidified. Then after that, we'll implement your ideas for this hardware and we'll start working on that fabrication. If you haven't had the chance to, please make sure that you subscribe, like our videos, and comment to help us out. We'll see you guys on the next video.
Today is the day I'm making a change, building